So I'll begin this lecture by having a review. What are our strong acids? Can you name me those strong acids? There's 6 of them.
HCl. Right?
We plug it straight into the pH equation. HCl. Go ahead, Royce. You're doing good.
Hydrochloric acid.
HBr. So chlorine is a hydrogen, hydrochloric acid. Bromine is a hydrogen, halogen. Hydrobromic acid, hydroiodic acid. Anything else? Perchloric acid. This is HClO4. Very good, Susanna. 1, 2, 3, 4, 5. HNO3. Nitric acid, and then just one of the protons of H2SO4. So as you recall, as you mentioned last week, we plug to get the pH, we plug it into pH's minus the log of the H plus concentration. Okay, just plug it straight in. Okay, what are weak acids? Okay, anything that's not this, anything that's not this, anything that's not these 6 acids is a weak acid. So I think the classic example we gave is acetic acid. Okay, whatever acid I give you on the exam, it's not this. Another one is formic acid. We'll do one a little bit later today. Formic acid, acetic acid. Okay. One thing is on the exam or quiz, I need to give you information to get the pH. What do I need to give you? Okay, the Ka. And what do you need to do to get the pH? You don't plug it in straight. Then you can plug it in, okay? You'll do an ice table, and then you'll get the H3O plus concentration. And for my tests and exams, there's no quadratic, so their weak acids will use something called LIA. What does LIA stand for? Low ionization assumption. Okay. And what's the threshold? Less than, very good, less than 5% ionization. Then you can use that. You can use this low ionization assumption on the exam. Okay, no quadratic on the test. Okay, then we'll move on to strong bases. Okay, what are you looking for in a strong base? Okay, what's this ion? Okay, you're looking for the hydroxide ion. Okay, anybody have me for? That's hydroxide ion, yes, sir. Anybody have me for Chem 1? Okay, those 3 in the back. Don't you remember I made you do flashcards? Oh, you don't? Okay, I pushed some flashcards on you. I let you use them on the exam. But one of the flashcards was hydroxide ion. Okay, so this is a strong base. Okay, it's a strong base. And what do strong bases do? They just grab protons like mad. Okay, like anything. They grab protons. What do strong acids do? They give protons like mad. Okay, crazy. Okay, they give protons. They acidify the environment by giving away H+. They protonate everything. U. And OH minuses, if it's strong, they will grab everything in terms of protons. So this is what we look for here. We plug in not straight into the pH equation. What do we plug it into? The pOH equation. Okay. So we plug that into the pOH. Here we plug it in straight to pH. And then finally the weak bases. Okay. So what are our weak bases? Okay, things that are in this table are weak bases. Okay, this is not something you need to know. I'll give you it, and of course I'll give you the Ks. Speaking of Ks, this will give you, I have to give you a Ka. Okay, what do I have to give you here? Not a Ka, but what? KB. Okay, Kb. So Ka, these acids will react with water to give you what? Okay, remember this equation. You should know this for the exam, H3O plus. These weak bases will react with water to give you what? They will react with water to give you OH minus. Okay, so that is a Kb. They react with water. All these things, these weak bases. A classic weak base is NH3, ammonia. Okay, what do we need to do here? Not only do you need the KB for the test, or quiz, or homework, or future chemistry, you'll need to set up an ice table, and then same thing, low ionization assumption is less than 5%. Right, so table of some weak bases. Okay, do not need to know it. Well, you need to know they're a weak base, but you do not need to know any of the structures. Okay, how do you know it's a weak base? It's not OH minus. And, you're kind of looking for amines. Okay, the amines like methylamine, the amines, ammonia. Yeah, these are equilibrium. Okay, very good. These are equilibrium. Okay, back and forth arrow. This is an equilibrium back and forth arrow. Okay, this is one shot, 100% source, or 99 to 100% source of OH minus, 99 to 100% source of H plus. Okay, these 6. So, yeah. So I will give you the Ka because every acid will have its own Ka. I'll give you the Kb. Every base will have its own Kb. If you want to find how if it's a weak base, you're kind of looking for the amines. Okay, that's a functional group that you'll learn in organic chemistry. Amines or even ammonia. Okay, these are weak bases. Very weak source of OH minus. Weak acids, a very weak source of H plus. And when I say H plus and H3O plus are the same thing the way I am teaching it to you. Okay. Right, so this table may be of use. I would check it, but you do not need to memorize it. And then let's remind ourselves of this trend here. Okay, as you increase the Ka, the pKa goes down. Okay, so if you started the quiz or on the exam, if you look at any study guides from the old exams posted on Canvas, you have to rank acids. Okay, so what would be the strongest acid in the list? Okay, it would be the one with the highest Ka. Okay, what would be the weakest acid in the list? The one with the lowest Ka, or on the flip side, highest pKa. Okay, so that's something you can do on your quiz, the homeworks, and on the exam, ranking 4 or 5 acids. We'll talk more about that as we approach the review. And I'm going to move on to the next page. Sadly, I printed this front and back, so my apologies. I wasn't trying to save paper, just somebody put it front and back. Okay, so you have this ugly thing here. So which way does the equilibrium shift in the following reaction, right or left? Okay, what do you guys think? Okay, we're in equilibrium, right? How do we know it's in equilibrium? Because the arrow points both ways. Okay, this is called acetic acid, so I'll tell you that on the test. Okay. This is called formate. Okay, the conjugate base to the conjugate acid of formate is formic acid. And this is acetate. Okay, do you see how they're named? Acetic acid, acetate. Formic acid, formate. Ascorbic acid, vitamin C, ascorbate. Okay, it's just the difference between removing a proton. Okay. So which way will this shift? Will this shift to the left or will it shift to the right? All right, so the pKa of acetic acid is 4.76. The pKa of formic acid is 3.75. So which is the stronger acid? Speaking of ranking acids, which would be the strongest acid? Formic acid or acetic acid? Okay, remember, what did we say about Ka and pKa's? Very good. Formic acid is stronger. Okay, why do we say that, Susanna? pKa. Yes. Okay, the pKa is lower. Okay, this is the best acid. Okay, this is the best acid. Ka, the power of the Ka. Remember, power is the minus log. So as Susanna, our classmate, mentioned, this has a lower pKa. So which is the better acid? I think you mentioned it correctly. This is a stronger acid. So which will give off protons? Formic acid or acetic acid? Which will give protons better? Formic acid or acetic acid? Which is a better acid? This is a better acid, so which way will the reaction shift?
More towards
Which is the better acid? Formic acid is a better acid. This will shift left. Okay. Formic acid is a better acid. This will shift left. Very good. It's better at giving away protons than acetic acid because it has a lower pKa. So formic acid is the better acid, or is the stronger acid. So shift left. This equilibrium favors the left-hand side. All right, so let's do this problem here. Okay, we have a lot of these in Chapter 15 and Chapter 16, so might as well get ourselves used to doing these types of things. Remember, like I said on the exam, you can assume low ionization assumption. And this is formic acid, so what do you think? What type of acid will this be? Strong or weak? Formic acid? No, this is a separate problem. Okay, this is a separate problem. So what is the pH? This is a separate problem. It's the pH of 0.6 molar formic acid. Okay, we're going to another problem here. Okay, forget this. We already solved it. Okay, the pH of 0.6 molar formic acid. So is this a strong acid or a weak acid? It's a weak acid. Okay, so if I were to draw a bottle of formic acid, okay, this is the formula for formic acid. Okay, I'll give you this. I'll give you the formula. Okay, what do acids do with water? To water. And this is a weak acid, as you guys mentioned, so you have to start this problem by writing the equation. So this is the equation you need to write. This is the Ka for formic acid. Okay, this is the Ka for formic acid. Okay, and what is the Ka value for this formic acid? Okay, I'll give you that. Okay, it's 1.8 times 10 to the minus 4. Given to us in the problem. Okay, so first step, write this. Otherwise, we won't give you points. Okay, so write this. Okay, 0.6 molar formic acid, and I'll give you the formula for formic acid. I'll tell you it's HCOOH. You don't need to know that. But you see, this bottle of 0.6 molar formic acid is not just formic acid. So what else is in there besides water? Besides water, what else is in there? H3O plus and HCOO minus. Okay. So we'll do our ice table because it's a weak acid. It's not one of our 6. So liquids don't go into the equilibrium. Okay, liquids do not go into the equilibrium. Neither do solids, but liquids do not go. So we have 0.60 molar, and this will be 0 and 0. Okay, as Susanna mentioned, this bottle will contain a little bit of products from this reaction in the solvent of water. So we want to figure that out. So some of it will go this way. This would be minus x, plus x, plus x. So this is 0.60 minus x. This is plus x. This is plus x. Okay. So these are our equilibrium concentrations. So let's plug it into the equilibrium expression. Ka is equal to H3O plus times HCOO minus divided by HCOOH. Why did I not add water to this? Because it's a liquid. Okay. Right, so now our Ka is given to us. I'll give you the Ka for formic acid. I'll give you the Ka for any acid. So this Ka is 1.8 times 10 to the minus 4. Okay. The product at H3O plus at equilibrium is X. The formate, HCOO minus, is X at equilibrium. So what's X times X? Okay, this is x squared divided by 0.60 minus x. Okay, so now on the test or quiz or homework, no quadratic, so we'll assume this ionizes less than 5%. This is called the low ionization assumption. So use the low ionization assumption, LIA. So we assume 0.60 minus x is about 0.60. Okay, you can do this. Okay, on the exam, we'll assume it's less than 5%. So 1.8 times 10 to the minus 4 equals x squared divided by 0.60. Okay, this is the assumption we're going to make. And then we will solve for x. So I'm going to do this in one fell swoop. 1.8 times 10 to the minus 4 times 0.60. Okay, we square root this. Equals x. Okay, 1.8 times 10. 1.8 10 to the minus 4. 1.8 times 10 to the minus 4 times 0.60. Okay, square root of that. Where's the square root button? My calculator. World's worst calculator is this. Alright, I think it's 0.0173. So if anybody can verify that for me, 0.0173 molar. Okay, so make sure you do that right. Let me just double check this again. 1.8 times 10 to the minus 4 times 0.60, square root that, square root the answer. Oops. Man, I'm getting a different answer. Okay, so we have 0.0104 molar. Okay. Right, so make sure you know how to do that on your calculator. I don't think I can. This is a pretty bad calculator in terms of its buttons. So this is what I get when I take this times this. This is after the low ionization assumption and square root it. But what does this x mean? Okay, what is this x? What does this x symbolize? Okay, what is this x? This x is what? It symbolizes the x's up there. Very good. Nice job. Okay, and one of the x's up here corresponds to the concentration of H3O+. So what is the pH? Okay, the formula for pH is minus the log of H+. This is minus the log of x, but we just figured out x as 0.0104. And what is this on our calculator? Minus the log of 0.0104. I'm getting about 1.98. 1.98. So pH has no units. Okay. pH has no units, so don't put units on the pH or POH or any of the Ks. But this has units of molarity, moles over liter, big M. All right, so this is kind of standard, what you'll be doing a lot of in your homework and in your chapter 16, as well as your lab sets. Okay, your problem set. So, and also this is kind of what you do on your test or exam. All right, let's wrap this chapter up here on page 19. What are we? How are we on time here? 10:30. All right, an equation for you guys is KW is equal KA times KB. Anybody know what KW is? Okay, this constant has a value of 1.00 times 10 to the minus 14. All right, so this is just another equation I'd like for you guys to know. I'll give you the KW. Right, and this KW is for this equation. The W stands for water. Okay, and this is at 25 degrees because we always quote the KW, or we quote KA and we quote KB at a specific temperature. KW from our textbook, and this value that we get from the textbook is at 25 degrees. So this equilibrium at 25 degrees. I mean, sometimes you raise the temperature, so it doesn't always have to be 25 degrees. All right, polyprotic acids. Anybody know what polyprotic means? What does poly mean? Okay, so these will give off multiple protons. Very good. All right, so let's give some examples of polyprotic acids. Okay, one of them we already know, it's a strong acid, and that's H2SO4. Okay, so is this polyprotic? The answer is yes. How many protons can it give? How many is multiple? 2. Okay, 2. It can give 2 protons. Okay, the first one is strong. Okay, the first one is strong. Okay, shall we go over that Ka? Okay, look at my arrows. Okay, so sulfuric acid is strong. Okay, and you're going to get this. This is the conjugate base to this conjugate acid. Okay, but, okay, what about this? Okay, hydrogen sulfate. What about this? Can this give off a proton? The answer is yes. But the thing is, it's weak. Okay, so this is one of the 6 strong acids I told you to memorize. But remember, as Susanna mentioned, this is a diproduct, or 2 protons. So this can react with water. Okay, look at my arrows, okay? This arrow is back and forth because there's a Ka involved. It's not strong like the first proton. This will give a proton here. And this time the conjugate base is sulfate, SO4 minus 2. So this is weak, okay? Look at my arrows, and this has a Ka. Whatever it is, you can look it up in your book, okay? But this is strong, and this has a Ka that's really, really large, so we just use it in one direction. Okay, this is an example of an acid that can give 2 protons. But which one is stronger? Okay, it's always the first one that is stronger. It's always the first one that is stronger. Okay, the second one and the third one, not so strong. All right, so that's a polyprotic acid. In this case, actually, we call it diproduct. What does the di stand for? Okay, this can give 2 protons. Okay. Let's look at this here. Anybody here drink a lot of Coke? Coca-Cola? Coke? You're a healthy guy. I drank, unfortunately, a lot of Coke. Actually, my wife said, I wish she drank alcohol rather than Coke or soft drinks. I'd rather have you drink beer and wine because I used to drink a lot of Cokes, but I slowed it down. I did have ginger ale on Friday. Anyways, Coke has something called phosphoric acid. Phosphoric acid. Have you heard of it? Have you read ever the label of Coke, phosphoric acid? In fact, if you look on YouTube, they take Coke.
Battery acid, right? Is that what involves the battery acid?
Yeah, it dissolves the battery acids, or
That's
they.
the main thing to heat up the corrosion.
Yes. They'll put Coke on a battery, car battery,
Corrosion.
or they'll soak an egg, and after a week the egg is you can remove the shell. It's hard boiled. Then they clean toilets. I saw a video where they clean toilets with phosphoric acid or Coke.
So is that one acid that does that?
But
All of that?
so how many? That's a good question. It's this one acid that does it. Okay, but how many protons can this acid give off?
3.
Okay, the point here is 3. So it's a triproduct. So let's look at the 3 reactions here. Okay, the 3 reactions. Okay, the first reaction has a Ka of 7.5 times 10 to the minus 3, pKa of 2.12. Is that strong or weak? Okay, compared to the other ones, it's strong. Okay, compared to this one, okay, dihydrogen phosphate. All right. So what I'm trying to say is this first proton is strong. Okay, what about this one? Can this give a proton? Okay, that's the second reaction. Okay, and this proton has a pKa of 3.21. Okay, and that gives you this. Now, can this give you a proton?
No.
Yes.
Okay, I got one.
Okay. So when it does, what will it give you? Okay, phosphate, inorganic phosphate. So, which of these is the strongest? The first proton, the first, second, or third? Which is the strongest, most acidic? Okay, why did you guys say the first? But why is the first the strongest? Because of the Ka is high and the pKa is low. Okay, why does H2PO4 minus, why is that the second strongest acid? Because the pKa is higher and the Ka is lower. Okay, why is HPO4 monohydrogen phosphate the weakest? The weakest in giving the proton? Because its pKa is really high and its Ka is really low. Look at that number, 10 to the minus 13. Okay, that's really small. Okay, it's still an acid, but 10 to the minus 13, that's a very, very weak acid. Right? Okay. All right, so polyprotic acids, the main thing here is the first acid is the strongest. What about the second? Weaker. What about the third?
Weakest.
Even weaker. Yes, weakest. Okay. That's the take-home point here. All right, I'll quickly go over 20 and 21. Maybe I'll go a little bit in chapter 16 with a little pen and paper work. Okay, which of the following acids is weaker, HClO2 or HClO3? So one of the things is which has more oxygen, HClO2 or HClO3? Well, obviously, HClO3 has more oxygens. So oxygen has something called polarizability or electronegativity. What is electronegativity? Okay, think of a vacuum cleaner. Okay, what does a vacuum cleaner do? It sucks. Okay, it sucks things, pulls in, sucks, pulls in. Okay, so what do oxygens do? By virtue of them being electronegative, it pulls and pulls. So the stronger the pull, the easier it is for this to come out. Because you have to see, if I draw the structure of these, you don't have to know the structure, but just draw it. HClO2. Okay, so don't need to know the structure, the Lewis structure, but this pulls. Okay, this pulls. Okay, contrast that with another hydrogen. Contrast this with another oxygen. Okay, there's more pull. Because as you mentioned, Marche, the oxygens are electronegative. They pull. If something is pulling this way, this way, this way in all directions, what do you think is going to happen? Okay, this proton will come off easier and easier and easier because electronegative atoms, like an oxygen, are vacuum cleaners. Okay, they suck up electron density. So more electronegative atoms, the more the pull on this molecule, the more this comes off. The more this comes off as H+. Okay? So which is more acidic? This is going to be more acidic. Which will be more weaker? Less oxygens, less electronegativity, less pull. What will this be? This will be weaker. Okay. So what's the take-home point here? Okay, more electronegative atoms, the more stronger that is as an acid, just because these electronegative atoms pull. Okay, remember from the very first weeks of class polarity, this idea of pulling. Okay, oxygen pulling, fluorine pulling, nitrogen pulling, they pull. When they pull, it's more likely that you can liberate the H+. It's more likely you can liberate the H+ when you have more pulls from the more electronegative atoms. All right, so this would be the weaker acid, less electronegative oxygen. So less pull. We say more electronegative atoms, there's more pull. All All right, the last page here, just wrap up on chapter 15. Right, so chapter 15, I know we had a spring break and then we had a test, so we had to have a disruption of spring break, we had a disruption of the exam. But this whole chapter 15 theme was on acids and bases, okay? And an acid is something that gives off H+, a base is something that gives off OH-. Some acids react with water to give you H+, that's Ka. Some bases react with water to give you OH-, that's Kb. But look at this here. This is sodium oxide. Sodium oxide solid can give you a base, okay, a strong base. So we have some sodium oxide in the lab, we dump it, we get sodium hydroxide, a base. Where are we getting this base? Okay, from the lab, sodium oxide. Okay, everybody breathe in. Everybody breathe out. So if you breathe out, you breathe out carbon dioxide. So this carbon dioxide reacts with water, and it gives you an acid. Okay, so this is an actual gas that gives you an acid. All right, here's another gas, N2O5. Okay, and this gas, I think it's laughing gas, but I'm not entirely sure. This gas reacts with water to give you what? A strong acid. Okay, so this gives you a nitric acid, correct? Okay, so this gives you a base. This gives you an acid. This gives you a strong acid. So it's very interesting how in this case, your body, your body can make acid. This happens, by the way, this happens in the blood. I don't know if you know this. I teach biochem here at this school, so they talk about this in the blood buffering. So anyways, just interesting information. It's not something I will test you on, but you can make strong acids and strong bases simply from reactions in the body, simply from household chemicals. You can make strong acids and strong bases. All right, and finally, Brunstad bases and Brunstad acids is what we were talking about. If you take organic chemistry, how many of you plan to take organic chemistry? Okay, a lot of us are taking organic chemistry. So there, it's Lewis acids and Lewis bases. This is what we're talking about. And this is what chapter 15 is. This is what your test is on. But there's a Lewis acid, Lewis base. So not going to test you on this, but just so you know, a Lewis base has something that has electrons. Okay? So this will give electrons. A Lewis acid is something that takes those electrons. Okay, so totally different. Here, what are we talking about in terms of what I'm teaching you for the exam? Okay, protons. Yeah, very good. Proton giver, proton taker. Here, the Lewis base is the electron donor. Again, not going to go into the details. A Lewis acid is an electron acceptor. So Brunstads have to deal with the transaction of protons. Lewis acids and Lewis bases have to do with the transaction of electrons. Okay? You'll learn more about this in your higher level chemistry classes. All right, so this is a wrap of chapter 15. I thought I'd do chapter 16, but I think I'll let it go. And so we'll start chapter 16. I made the exam April 4th. Anyways, I made the exam in April, so this gives us some time to finish chapter 16 and have a review. Your next test will be on chapters 15 and chapter 16. And I made the test April something. We'll finish chapter 16. We'll have our practice test review for you guys in the lab. Make sure you work on your acid-base problem set. I'm running behind in lecture, but I'm moving forward in the lab. I promise you, what you're doing now in what you're doing now in lab, I'll cover it in lecture. Okay, just a little behind, but we'll cover it. All right, have a good day. Have a good day. Okay, do not come here at 2 o'clock.
No, not to, right?
Okay. No lab. You have a break today, but you won't have a break in terms of actual lab, an actual lab.